So today we're going to be doing completing the square, where our a values are something other than 1. And the whole idea for this is we're going to factor out before we're beginning. So our first two is just a refresher for what is factoring, or what is completing the square. And the whole idea is that I want to create an artificial trinomial using these first two terms. I want to kind of push that off to the side and deal with it as it shows up. So I'm going to say x squared minus 40x, and I'm going to move that 10 over here. And that gives me some room to deal with this. And I know for a perfect square trinomial, this is going to be twice the square root of this term. So I'm going to cut that in half. Half of 40 is 20. So I'm actually going to be adding 20 squared, which means if I add it on the same side, add it and subtract it. Add and subtract 20 squared. What this does right here is over here, this allows me to factor very quickly x minus 20 squared. And then I just deal with what's over here. Well, that's going to be minus 400 plus 10. So all in all, that's going to be x minus 20 squared minus 390. So let's take a look at another one. That one worked pretty well because I had an even number, so it was easy to divide, but it's no different if I have fractions or odd numbers. I'm going to shove that thing off to the side and say x squared plus 5x and move my 11/4 way over there so that I can say, okay, what's half of 5? That's 5 halves, whatever that thing is, squared. If I add it, I'm going to take it away. 5 halves squared, because I know that that is going to work out to 0. But it does allow me to very quickly factor this into an x plus 5 halves squared. And then I just kind of deal with whatever this is over here. Let's see, 5 halves squared is going to be minus 25 fourths plus 11 fourths. That's going to be 11 minus 25. That's a negative 14 fourths. So x plus 5 halves minus 14 fourths. That reduces down to a 7 halves. So x plus 5 halves squared minus 7 halves. Perfect. So we see that even if we have fractions, square the fraction, combine these two things. Even if I have an odd number, or if I had a fraction right here, divide it in half and make sure that that's squared so we can balance these two things out, and that just poops down into this, and then we're done. So the big question of what we're dealing with today is, what happens if I have something out here? How do I deal with that? Well, the whole reason of how we deal with that, actually, let me pick a different color. I'm going to pick purple, is I just pull out a negative 1. I'm only going to pull a negative 1 out of the first two terms. I am, just like before, going to throw my 77 way over here, but it's going to give me some room for my x squared plus 18x. And I'm going to make sure this is set up for a perfect square trinomial. Now, if I were to say, okay, what's half of 18? Let's add a 9 squared. And if I were to subtract a 9 squared, that looks balanced, right? But if I were to take this a step further and FOIL this out, I'm not actually adding a 9 squared. I'm adding a 9 squared times this. So I also want to take away a 9 squared times that. So add a 9 squared times this, take away a 9 squared times that same thing. And we would see that if I were to work this out, so let's say that was a negative x squared plus 18x, actually that's a minus. So minus 18x, that's going to be a minus, let's just call it 81. We're going to simplify it. So there's my minus 81. I have plus 77. 9 squared is 81. That makes it a negative 81. That makes it a positive 81. And so we see that by multiplying this thing on the outside, we get them to balance out. And that's really what we want. But again, this makes it very easy for us to say that's x plus 9 squared. I still have my -1 out front, but then I just deal with whatever this is. I say, okay, well that is 81. That's a -81. Now it's a positive 81, so what is 77 plus 81? Well, -1, x plus 9 squared. That's going to be 159. There we go. Perfect. And so let's do one more of those. What we're seeing is that if I have a number out front, my first job is to just go ahead and pull it. And then I'm going to say, okay, I'm going to divide that out so I get an x squared. Divide that out so I get a plus 10x. But remember, I just moved this 10 way over here. I don't actually do anything to it. I'm going to take this. Half of 10 is 5. Let's add a 5 squared, which means I take away a 5 squared times 2. Because I add a 5 squared times 2, take away a 5 squared times 2. It's going to keep my equation balanced. This very quickly factors down to an x plus 5 squared, where I still have my 2 out front, and I just deal with this as it is. 5 squared is 25, -25, -50. So there we go. So y equals 2x plus 5 squared minus 40. Perfect. And so now that we've seen that, I want you guys to pause the video, try number 9, unpause it when you're done, and see how you do. Okay. Let's take a look at how that works. So my first thought is pull out this 4. So I'm going to divide that by 4 to get an x squared. Divide that by 4, which is going to give me a 15x. Leave myself some space, plus 1. I'm going to say, what's half of 15? Well, that's 15 halves squared. If I add it, take away 15 halves squared times this thing. And that's going to give me a very easy x plus 15 halves squared times 4. And then I just deal with whatever's left over here on the end. Let's see, so 15 halves squared, that's going to be 225 over 4 plus 1 minus 225 over 4 times 4. Well, those are going to cancel out. It's going to be a plus 1 minus 225, and that's going to be a minus 224. There we go. Boom. How'd you do? And so now that we're familiar with that process of just factoring out that leading coefficient, that works even if the leading coefficient is not a whole number. So for example, this is a half, so I'm just going to factor out a 1/2. Now, what that's going to do is if I divide everything by half, remember, dividing by a half is the same thing as multiplying times 2. So that's going to turn that into a minus 20x. Minus 18. So what I'm going to do is I'm going to say, hey, that's going to be a plus a 10 squared. So plus 10 squared times 1/2. Remember, still get multiplied by that leading coefficient that I just pulled out. So that gives me the ability to say, hey, I have an x minus 10 squared. I still have my 1/2 out front, but easier now than last time is I just get to deal with that. Ooh, careful. I almost broke the cardinal rule. I added twice. That should be a minus. So if I added 10x, or added 10 squared, I take away 10 squared. So that's negative 100. Half of 100, that's going to be minus 18, minus 50. And remember, for some of you, you might say, well, no, shouldn't that be a plus? Remember, that's minus 10 squared times 1/2. Remember, the immediate base rule says that only that 10 is squared unless that negative or unless anything else is included in an additional set of parentheses. So that'd be 100 times 1/2, be negative 100 times 1/2, which is negative 50. And so right here, we're left with y is 1/2 x minus 10 squared minus 68. Perfect. And there we go.